So for this, would you need to minus the highest from the lowest?
Yep.
So it's the frequency we're doing, right?
No. The range of the mass.
So would it be 6 to 6.5 minus 4 to 4.5?
Kind of. How would you do that?
Would you get the midpoint?
I would do the biggest take away smallest.
Oh, so it'd be 2.5.
That's my guess. That is my guess. Minus 4.0. 2.5, yep. Okay. Interquartile range. How do we do that?
Is that a quarter n plus 1?
Yep.
Wait, no, isn't that the lower quartile?
So that'd be the lower quartile, yeah.
Which one do we use to get the lower quartile? The total?
Yeah, it'll be a quarter n plus 1. What is n?
And the total amount of frequency?
Yep.
Okay, and that will be...
120.
119, I got. Oh, 120.
120. In fact, let's just say it's a quarter of 120, because it won't make much of a difference.
Which is 30.
Yep. And so it's the 30th elephant.
Yeah.
Okay. What is the weight, the mass of the 30th elephant?
The mass of the 30th elephant is between 5 and 5.5 tons.
All right. Can you get more exact than that? How do we do it?
We have a line.
Yep.
In the top left it would be 5, top right would be 5.5.
Mm-hmm.
And there'd be a line closer to 5.5. And it'd be X. Below it would it be 30?
Mm-hmm.
And then bottom right would be 31. Bottom left would be 23. And then we use the equation.
Do you remember it?
Is it? No, I don't think I remember.
It is. So this one on the left, x minus 5.
And then it's 5.5 minus 5.
Yeah.
And then on the right it's 30 minus 23 on the top.
Yeah.
And then 31 minus 23 on the bottom.
Yeah.
And then we can put that on the calculator.
Yep. You get 4.87.
Okay.
4.87. Wait, that's not in between 5 and 5.5. It should be 4.5 to 5. Shouldn't it? 13, 36. Yeah. We wanted the 36th elephant.
Okay.
So that's 5.0. That's 4.5. Yeah. Then you would do the same for... so these are what, 13 and
23.
No, 36.
36.
Then we do the same for the upper quartile. And what would you do with the two answers?
Would you minus upper quartile from the lower quartile?
Yep. And then how would you do part C?
So would you use... Is it 10 over 100?
That'll work. Yep.
And a 90 over 100?
Yeah. So it'd be 12, the 12th elephant and the 9 times 12, 108th elephant, something like that.
Yeah.
Yeah, it just take a long time using that equation, and you just do bigger, take away smaller.
Mm-hmm.
That's fine. Yeah. Let's see. Median and interquartile. Median interquartile. What is part A?
500 minus 400,
Yep.
which is 100.
Let's see. Is there any other ones? Explain why the actual range will differ.
Because it says there's 13 between 475 and 500, meaning that it might not always be the highest mass of the kitten might not always be 500 being the maximum. It could be like 487. That could be the highest mass of a kitten. Same goes with the minimum.
True. I would stick with the higher one because a kitten could be exactly 400.
Yeah.
But it couldn't be 500 because it's not or equal to.
Yeah.
It will be less than this. It is unlikely there is a value of 400 and there cannot be a value of 500. So yeah, say both of them. Yeah, it's unlikely one, impossible the other.
Yeah.
I heard.
Let's see. Between 2 and 6 minutes. How could you do this one?
Okay. So, for this, would we need to... Which percentile do we need to work out?
What percentiles would give you the middle 90%?
The highest one, so 16 and 20.
What percentage of the population would be in between the 30th and 70th percentile?
The one in the middle.
Yeah, what percentage of the population? So you got 0%, 100%, 30%.
So would it 40% of the population?
Yeah, and so that is 40% in there.
Yep.
And so this one, what percentiles give you the middle 90%?
Oh, so it'd be 5 and 5.
Yeah, so it would be the 5% and 95th percentiles.
Yeah.
And let me see. Yeah, so that would be like 5 over 100 and 95 over 100 using the same method as the mean. Okay, measures of spread. I think you're all right. Measures of spread, range, interquartile range, and interpercentile range. Those are usually done with the median.
Yeah.
For good reason. They knock out outliers. Very, very large, very small. Variance and standard deviation usually match up with the mean.
Yeah.
It's just another measure of spread, like measures how spread out the data is. The way range, well, this one uses all of the data, so it includes all parts of the data, including outliers, that type of thing. Okay, find the variance and standard deviation of the 7 students. Let's see. So the standard deviation is root SXX over n. So the variance, it's the difference between, you get the difference between all the x's and the mean. You square them, you add them all up, and you divide by n. There is this much more convenient formula to use. Hang on.
Yeah.
We have to make sense of it. It is the sum. No, it's the mean of the squares minus the square of the mean.
Yeah.
Let's see. Ooh, I think it's... where did it go? There it is. Cut, undo again. There we go. Okay, so let's try to use this one.
So it wants the sum of all the numbers and then squared on the top.
Let's see. So the sum of all the numbers, yep, what is that? Sigma x?
I think it's 36, right?
20. So that's 36. What is n? Number of numbers?
7.
And they want the sum of all the squares. So you'd square each number and add them up.
Okay.
You can use calculator.
Okay.
64.
I got 218 on the top.
Okay, and so what values go where?
So 218 on the top over n, and then
What's n?
minus n is 7. Minus would it be 36?
Yep.
Squared over n, which is 7.
Calculator.
Okay. I got 230 over 49.
49. As a decimal? 3 6 figure?
As a decimal, it's 4.69 to 3 decimal place. To 3 significant figures.
Okay. So what's the mean? Mean is about 6 point something. Yeah, sorry, that's the variance. Standard deviation? Standard deviation is the square root of the variance.
So you square root it?
Yeah, square root answer.
Okay. Well, as 4.69 or the full answer?
Full answer. Use answer key.
Okay, that gives you 2.17 to 3 significant figures.
Okay, and so the mean is roughly 6. 6, 7, 8, 9, 10, 11, 12. And then 6 goes down to 0. Looks about... alright. 2.17. Yep. Now let's see. Calculator.
Yeah.
Let's see. Statistics. Number 6.
Okay.
This is one variable. Does your one look like this?
Yeah.
Okay, so 3 equals 4 equals 6. Do you have that?
Yeah, I've got that down.
Option.
Yep.
And one variable calculation, which is 3.
Okay.
So x bar, so the average is 5. Is that right? Did I put mine in right? Yep. Sigma x squared is 218. Sigma x is 36. Delta x, second from the last, is 2.17 roughly. And yeah, that's what we needed, the standard deviation. Above it is delta squared x, the variance, 4.69. Yep. Okay, grand. This tells you how much the data is spread out. So if the higher the standard deviation, the more spread out the data is. Just like the range. The bigger the number, the more spread out, the highest from lowest type of thing. Let's see. Same idea. Let's see. let's make this easy. Calculator. Shift menu for setup.
Okay.
Press down.
Yep.
Statistics.
Yep.
And turn on frequency.
Okay.
Does it look like that?
Not yet.
Alright.
Let me get this back up. Yeah, now it does.
Okay, so their table goes across, ours goes down. Put in the X's.
So it'll be 36, 35 for the first one.
Mm-hmm.
And then 36, 37, 38. A frequency of 3, 17, 29, and 34.
Mm-hmm. What's next? Do you remember how to get standard deviation?
Shift option.
Just option.
Option. And then down one, and then no. And then it's 3.
Yep.
Yeah. And it's 0.86. I think.
Option 3. So standard deviation is 0.86. What are the other values of interest?
X bar is 37.1.
And what is X bar? What does that represent?
That represents all the X's, like the added together. Frequency.
That's sigma X. X bar is the mean.
Okay.
Yeah. What's the variance?
Pardon?
What's the variance?
The variance
Mm-hmm.
is that 0.74.
Yep. That's it. Standard deviation squared. Standard deviation is more important. Okay, great. Okay, how do we deal with this?
Okay. So for this, can we still use the calculator, but we find the midpoint?
Yeah, exactly. So, how would you start this
Okay.
one?
So you have the same thing, but for the first one, for the X, it would be 2.5.
And the frequency?
And the frequency would be 4.
Yeah, and you'll be fine for the rest of that. It's
Yeah.
exactly the same. Okay. How about this? So this time they gave us the summary statistics. We go to our formula booklet. We look up the standard deviation.
Yeah.
It has this strange thing that we need to make sense out of.
Okay, so we can sub in for sigma W, which is sigma X 241 into the equation.
So where does that go?
So on the top it would be 241 squared. Wait, no. It would be 5,905
Yeah.
over n.
What's n?
Wait, do we know what n is?
It's in the question.
Oh, 10.
Yep.
Minus brackets 241 over 10, and then the whole bracket squared equals.
Yep. Put it in the calculator, get the answer, write it down. Good. Let's see this one. I wanna no, I just wanna answer. I need the answer. I don't have it. Let's see. So look at this beauty. Okay, so exam question.
Okay.
Hold on. Use your calculator.
Yep.
Work out the mean. Work out the standard deviation. 2 marks in total. 1 mark for mean. 1 mark for standard deviation. Meaning.
Well, it gives you both in the calculator.
True. So you're not going to get any extra marks for doing all the fancy stuff.
Calculation. Yeah.
Yeah. Okay, let me see. So 6.68. And standard deviation is 1.02. Okay, part B.
Okay. So the mean number of ladybugs went up, but the standard deviation went down.
And so, in the context of the question,
So what would standard deviation mean in the context of the question?
let's do mean first.
Okay, so there are more ladybugs on the rose bushes.
Yeah, so on average, there's more lady birds on the rose bushes 2 weeks later.
Yeah.
Yeah, that's increased. Okay. And standard deviation decreasing. Any idea what that represents?
No.
So it's like a smaller spread.
Okay.
And that's like they're more. Let's see. The number of ladybirds is now less spread out.
Yeah.
So here you had like from 8 to 5, maybe it'll be from only 8 to 4 or something like that.
Okay.
Or there'll be more clustered in the middle. Fewer will be 8 and 5.
Yeah.
The mean number of ladybirds is higher on the second day, but there was less variability. Okay. Use your calculator to find mean and standard deviation. How many students? Oh, I don't have the answer. 1 second. Let's do this one. So how many ladybirds had... How many bushes had 1 standard deviation more than the mean for this one?
Well, what's the mean? 7.1.
No.
For 16.
For part A.
Oh. Well, the bushes at the bottom, like the 7 and the 8.
So how many bushes had 1 standard deviation more than the mean? What is 1 standard deviation more than the mean?
The spread, more spread than the mean.
No. What is the mean plus 1 standard deviation?
Mean it's 7.7.
1.02. Yeah, 7.7. And so how many bushes had more than that?
But how do you know?
Table. How many bushes had more than 7.7 ladybirds?
1.
1 category. How many bushes?
8 bushes.
That's the ladybirds?
16.
Yes. Let's see. How many bushes had 1 standard deviation less than the mean?
One. Well, 11.
Correct. There you go. Let's see. Let's see this one. Claims that he completes 80% of his route. Okay. Let's see this one. 0.54. So that is 5 and 0.54. So the mean is 5, standard deviation is 0.54. Part B.
Okay. Wait, so am I supposed to say if it's right or wrong?
Yeah.
Okay. So do we need to work out what the standard deviation is for the data?
Mean is 5, standard deviation 0.54. So I did part A.
Okay. So he's saying that he completed it in 0.54 hours.
No?
But it says he completed it within 1 standard deviation.
So within 1 standard deviation of the mean.
So would you do 5 minus 0.54?
Yeah.
Which is 4 No.
Mm-hmm.
What, so would it be 4.46?
Yeah. Within 1 standard deviation of the mean would also include 5 plus 0.54.
Which is 5.54.
And so how many did he do in between 4.46 and 5.54?
He said he claims that he completed 80%.
So 4.46, that's going to be roughly there.
Yeah.
And 5.54, that'll be up to there.
Mm-hmm.
And so how many papers or whatever is that?
It's 15.
So that's 15 out of how many?
24.
And what is that as a percentage?
Well, I got 62.5. So that's incorrect. He's incorrect.
Yeah. 62.5%. Yeah. So if it's within 1 standard deviation of the mean, then it's the mean plus or minus 1 standard deviation.
Yeah.
So it's in between 4.46 and 5.54. Yeah, that was 15 out of the 24 in total. Let's see. This one. That one's fine. I could go way back, I think. Yeah. Let's see this one. Oh, wow. Okay. About this one.
Okay.
A set of 6 numbers has a mean of 5 variance of that. Let's just find the variance of all 11. How would we do that?
Okay.
I
don't know.
Hang on. Before we do that. No, I'm going to leave that. I think it's more work than it's worth. Doesn't seem typical. Oh, I forgot the question for this one, did I? I need to get the question. Oops. Get question. Standard deviation. Yep. How about this one?
Okay. We don't know what N is.
August.
What? So is that the day of the month?
No,
like the month number.
It is daily.
So when you do 7,374.7 divided by n, what would n be?
Days in August.
Oh, is it 31 or is it 30?
You tell me.
I don't know this.
Ooh, it's 31.
Okay, thank you. Minus 477.4 over 31, all in brackets, squared.
Yeah, that's grand. Let's see this one. Okay, how about A?
Okay. So would you do 2,317 divided by the days in June?
Do you know?
31.
30.
Oh. Minus 243 over 30.
43,
All squared in brackets.
30. So that gives you. Okay, I don't know the answer. Get the answer for that one. Let's just see this one. The highest recorded wind speed was 17, lowest was 4. Estimate the number of days in which the wind speed was greater than 1 standard deviation above the mean. I better work this thing out. I tell you what, you calculator. What is the standard deviation?
Okay. Of which?
For the part A.
Okay. So can you put that into the calculator?
Yep.
Okay. I got 11.62 to 2 decimal places.
I'll say 11.6.
Yep.
And so how do we do part B?
Okay. So we know the highest and the lowest recorded wind speed. So would you use the line thing again?
I don't know. The number of days in which the wind speed was greater than 1 standard deviation above the mean. What is the mean?
It's X bar.
Yep. How do you get X bar? For when you have summary data like this.
Do you do 243 divide... Wait, you can't. You don't know how many number... Oh, you do it... Would it just be 243 divided by 30?
Yep. What's that?
8.1.
So that's 8.1. And so, hang on. That is the variance. We need to square root that 11.6.
So we need to square root the answer.
Square root 11.6. Yeah.
Okay.
You can press up if
Okay.
you want to retrieve it.
3.4 to 1 decimal place.
Okay. So standard deviation of x is 3.4. And so what is 1 standard deviation above the mean?
But how do you get that?
Mean plus 1 standard deviation.
So that means 81 plus 33.4. No, 8.1.
Yeah.
which is 11.5.
And so we have to estimate how many. I think we'd need the table or something in front of us. They give you the thing. So you just count how many are above 11.5.
Yeah.
And there's other ways to do it.
Yeah.
I won't get into them now. That stuff.
Probably a tick.
It's alright.
Yeah.
Coding. That's when you encode the data and then you decode the data. It just makes your life a bit easier. So instead of doing like this one, they're all in the 300s.
Yeah.
What you can do is subtract 300 from all of them. And then at the end, you can just add 300 back as needed.
Yeah.
Okay, so use this coding. So you subtract 300, then divide by 10.
Each of them?
Yep.
So you get 3.2 for the first one. 5.5. 0.6. 1.7. And 4.
Mean and standard deviation of the coded data.
Okay.
Yeah, we need to do it. And you can always use the calculator, the X bar and delta X thing.
Okay. The statistical stuff.
Yeah.
Okay. So for the frequency section, would it just stay as 1?
Yeah, that's right.
Okay. I got mean is 3.
Okay.
And the standard deviation is 1.7 to 1 decimal place.
Okay, and I'm calling it Y bar because it's the mean of the coded data, and these are X up here. Yeah, Y and X. And use your answer to part B to calculate the mean. So now that we have the coded data, work in reverse, decode it to go what would be the actual mean for this data up here.
So we need to work backwards.
Yep.
But how do you do that with just the mean and the standard deviation?
Decode the data. So we encoded the data. You could create a formula by making X the subject.
So you could divide by 10 on both sides. So it'd be y divided by times by 10.
Yep.
So it'd be y times 10, and then you could plus 300 on both sides.
That's it. And so X is 10y plus 300.
Yeah.
Okay. So X is 10y plus 300. And so what is X bar?
You do 3 times 10 plus 300.
What's that?
Which is 330.
Okay. Get the mean of these up here. Does it give you 330?
Wait, what do we do?
Find the mean. So just like actually find the mean for those 5. See if it's 330.
Okay. Okay, so I got 330.
Great. So that's correct. Okay, standard deviation.
So this time would it be equals, would it equal 10 times, would it still be the same equation, 10 times 3 plus 300?
Let's try. And it's what was the standard deviation of y?
330.
That was the mean of x. Y is the coded
Oh,
data.
1.7.
Yeah.
So it'll be 1.7. Oh yeah. And then plus 200.
Yeah.
So it'd be 17 plus 8, so it's 317.
370 in. Put these into your stats thing, your table. Get standard deviation,
Okay.
frequency of 1.
Okay. So I put that into the frequency.
No, frequency is 1 for each of them.
Okay. Okay, so we have. And then option. Yeah, I got. Wait, for which one?
So does X bar say 330?
Yes.
What does delta X say?
Which one's delta X?
Standard deviation? I think it's the fourth one.
Oh, which 17.16 for the delta X.
Aha,
Delta squared X is 294.8.
that's fine. So the standard deviation is 17, not 317.
Yeah.
Why is that? It is because it is a measure of how spread out the data is. For this data here, the range is 355.
Minus 306.
Yeah, 355 minus 306. What would happen if I added 300 to both of these numbers?
They become 655 minus 606.
And so the range for the first one be 49.
They'll both be the same, won't they?
Yes. And so adding or subtracting a value won't change the standard deviation.
Yeah.
And so this bit here we don't do. For the mean, you multiply and add. For the standard deviation, you only multiply.
Okay.
To decode it, because that is the only thing that will change it.
Yeah.
Because if you add 300 to everything, it won't change how spread out the data is.
Yeah.
All right, let's see. Okay. 1 second before let's keep it a bit more normal. It's not bad. All right, how about this?
Okay. So would you want to make it x equals x bar equals? Would it be x bar or just x?
You could do x in general.
Okay. X equals 200 plus 2. Wait, would it be 1.5?
Y bar is 1.5.
So it'd be x times 200 minus plus 65.
Times 200 by both sides. What do you get?
200y.
Yeah.
Plus 65.
Yeah.
So it'd be 200 times 1.5 plus 65.
Yeah.
So it'd be 300 plus. So it'd be 365.
Let's see, 365. Great. So I need the answers for these.
Yep.
Let's see this one. Okay, let's try this.
Okay. So it'd be x equals 100y plus 20.
Yeah.
So it'd be 2000 to 2020.
20. Okay. Yeah.
And then for the other one, it would be 48 times 100.
Hang on. Why is that there? We need the standard deviation. That's sigma y squared. What is the n?
Isn't n 2020?
N is 10 supermarkets. Okay. And so what's standard deviation of y?
48 times 100.
We'd have to work it out. So we'd have to do 48 over 10 minus 20 over 10 squared. And what is that?
Okay. Uh, 0.8 or 4 over 5.
Okay. And so we want, so that's delta y, we want delta x.
So we can use the equation but rearrange it. And would the rearranged equation be delta x equals x times 100?
Y times 100.
And is that the answer? So it'd be 0.8 times 100.
Yep.
It's 80.
80? That's great. You did 89.4. Did you square this thing?
Yes, I did.
40 whole thing?
Yeah, I put in 48 over 10 minus brackets 20 over 10 close brackets squared.
This thing. Squared. Sigma y squared is 48. Sigma y is 20.
Do we square root it or something?
We square root it. That's it.
Yeah.
Sorry. Square root it.
So do we square root 0.8?
Yeah.
Which is a bunch of numbers, and then you times it by 100.
Yep.
Which is 40 root 5 or 89.44.
89.4. Yep. Great. Good. How do you get variance?
Forgot.
You don't square root it.
Okay. So is that what we did before? Just don't square root it?
Yeah.
Okay. That makes sense.
So that's okay. Let's see. So the coded data is there. What is this? Given that a typical salary, explain is more sensible to code her raw data. So why do you code raw data? Typical.
What, to make it more like compact?
Yeah, it's just easier to work with, I think.
Yeah.
Coding makes large numbers easier to manage.
Yeah.
Okay, she records the salaries of 8 people. Uses this coding. Her coded stuff is this. Given that the mean is this, The variance is that find the values of A and B. So what was the coding? How do we work in reverse?
Okay. So we use the equation. So we do it as 1634 over 8 minus brackets 104 over 8 squared.
No. It's like they gave you the answer and you have to go get the question. So it would be like this one. If they gave you 2020 and 89.4, or I think it's like 2020 and 0.8, you would have to figure out that this is minus 20 and this is over 100.
Okay.
And so,
but which one's the answer?
in this case, you have to find like what was the coding that gives you this coded mean for the actual mean being this.
Okay. So we need to there needs to be a number that gets divided by and also multiplied by. I don't know, minus.
Yeah, so I would make x the subject basically.
Okay. So it'd be x equals ay plus b. Oh no, it'd be a plus b minus y.
Well, let's just say, what is ax equal to?
Ax is equal to by.
How do you get rid of plus b?
Minus b.
Yep, minus b from both sides. What do you get?
Y minus b.
So y minus b equals ax. And so what is x equal to?
Y minus b minus a.
Opposite of times a?
Oh, you divide by a, all over a.
So when we subbed in, okay. So how can we work in reverse?
So we know that. Alright, let me try this. So could you put into the calculator x over 8 minus x over 8 squared equals 165,000 and then work it out?
So this one here, sigma y is 104. So that's like the y. 104 minus b over a gives you x bar. What does the x mean?
The mean.
Yeah.
So what would you do with x bar?
What is x bar? What is the mean?
165,000.
Yeah, so that's one equation. Can we get a similar one for standard or for variance?
Would it be 888 and 8? Would you put that big number as 104 minus b over a?
With variance, I believe you don't subtract, isn't that right? You don't add or subtract?
Oh, okay, so it's that over a.
I think so.
But you need to divide it by 8.
So that over A gives
Yeah.
you 8. Yeah, so divided by 8, what do you get?
Okay. I got. Wait, did I get the numbers right? Yeah. I got 110 1101 562 50.
And that's kind of why they coded it, you know.
Yeah.
So that's A. How can you use that to get B?
You put A into the first equation we got.
Yeah. So that goes there, and you could you just solve it. So 104 minus x all over answer equals 165,000. Shift solve. So it's just working in reverse. That's working.
Yeah.
And yeah, you can see why they coded it.
Yeah.
It's a very big number. Yeah. Any questions there?
No.
So that's just working in reverse.
Yeah.
Oh, hang on. A is that. Hang on, I was worried about this. I think so. This is variance. Let me see. It's variance. How do we get standard deviation? No, variance. So maybe it's not that simple. This was 8 banks.
Yeah.
And so that would be variance. And the answer to that would that over A equals 16500. But is it a different answer? Yeah. It is a different answer. Sorry, we put in X. We should have put in Y. So that is the variance of Y.
Yeah.
104 over 8 squared. So that is 35.25.
Yeah.
And so we divide that. So that divided by A equals 165.
Yeah.
Is that right? And so it would be that over 165,000, but not take away anything. What am I working on? I don't know. I'll have to take a look. I want to see if the exam questions are similar to that. If this is a in reverse type, I'll take a look. The mean standard deviation. Let me see this. The data was coded. Yeah, you just get the standard deviation and sub it in. Hang on. Oh, I don't know the answers. All right. It's lots of similar stuff. Mean standard deviation.
Yeah.
All right. Coding. What do you give yourself?
Probably between a tick and a half.
Well, that's chapter 2. Anyway, how was that for you, Adam?
That was great.
And so chapter 3 next time?
Yeah.
Any questions in general?
No.
All right. Well done, Adam. You did great.
Thank you.
I look forward to talking to you again next time.
You too. Bye.
Cheers. Take care. Bye-bye.